Okay, Bismillah ar-Rahman ar-Rahim. So today we're going to talk about classwork number 8, which is the orthographic projection. Orthographic projection. So what do we mean by orthographic projection? This classwork is the most important classwork in the total course. So you have to focus on that, and you have to practice as much as you can on this classwork because it's very important. Okay, and I'm gonna give you the idea of this classwork. Okay, very important classwork, so focus on, and please just give me your attention to this classwork. Okay, so in the previous classworks, especially in classwork 3 and 4, we used to give you the isometric, and this isometric has a dimension, and we ask you to draw the same 3D model. Okay, we give you all the dimensions, we give you the 3D model, and we ask you to do that. Okay, now what is the orthographic projection? Okay, simply we just give you the front, the top, and the right. Okay, but without the isometric, without the 3D model. Okay, we give you the total or the full dimensions, and you have just to draw the 3D model. Okay, what do you think about that? If you just give you the front, the top, and the right, and you have to draw the 3D model, maybe it will be difficult. But how about if I just give you one of these planes? We just give you the front or the right with full dimensions, or the front and the top, and we ask you to draw the 3D model. Okay, so this is the orthographic projection. We give you, like in the drawing sheet, the front, the top, and the right without the isometric, and we ask you to draw the 3D model. So, and we just give you two planes. Actually, you don't need the three planes. You just need two of them, front or top, or front or right. Okay, so in order to make it easy to you, we have 7 rules, 7 secrets. Okay, to draw this 3D model, to conclude the 3D model from just 2 views, from the front or the top, or front or the right. This is what we call it orthographic projection, is to conclude the 3D model from just 2 views or three views. So what are these rules? I have to tell you that you have to focus, okay, because it will be easy, inshallah. After these 7 rules, this subject would be easy to you, inshallah. So rule number 1, the extrude from the opposite side. Rule number 1, the extrude from the opposite side. What do we mean by that? Suppose you have this square from the top. I'll give you an example. Okay, like for example, if you have a Google Map, the Google Map application in your phone, okay, you will find all the buildings, okay, in square shapes or rectangle shapes. Okay, you will find all the buildings in square shape, but can we know what is the height of these buildings from the top? Like for example, I can know that this building has 4 floors, this building has 3 floors, this building has 2 floors, or the height of this building is 5 meters, this 4. Can we do that? Know that from the top? No. So we need the opposite view. What is the opposite view for the top? The front. So how can we know then the extrude of this square? I cannot know the extrude or the height of this square. I just can know that from the opposite side, which is the front. Okay, which is the front. So this square, I have to give it an extrude of 30 millimeters, which is the height of this building. This is the height of this part. Okay, Now if you have the same thing, if you have square in the front, and you want to know what is the width of this part. You can, if you have just front and right, we can know the extrude of this this part from the right, which is the opposite side. So we can know the extrude for any drawing, okay, from the opposite side. Very easy. Okay, so this is the extrude from the opposite side. I cannot know the height of this building, I can know that from the opposite side, front, or if I have front and right, you can know that from the right, and so on. Okay, rule number 2, the inclined and upright surface. The inclined and upright surface. Suppose that you have this rectangle from the front. Okay, this rectangle. Can I know that this rectangle is upright, has an upright surface, like this, upright vertical surface, or it has like a diagonal or inclined surface? Okay, I cannot do that. From the front, both of them, I can see that they have a rectangle shape, but you cannot know if this surface is upright, vertical, or has a diagonal surface. We cannot know that. Just from the right, I can know that. Okay. So another example, for example, you see this curved surface. I'll see it from the front as a curve, as a rectangle. Okay, but I cannot know that if this surface has an upright surface or inclined surface. From where can we know that? From the right. Okay, from the right we can know about if this surface has an upright surface or inclined surface. Let me give you an example. So this is the front. I see that rectangle, and I know from the right that this rectangle has an upright surface. If we look in the left side, we can see that this is an upright surface. So from the front I can see it in a rectangle, and from the right I can see that this is the extrude, and this is an upright because of this line. Okay, so focus on the left line. Okay, here I know that this rectangle has an inclined line or diagonal lines or diagonal surface from the left line. Okay, so it's okay. It's clearly that it's rectangle from the front, but from the right I know that it's has a diagonal surface, okay, or inclined surface from the right. The same thing with this example, rectangle, but from the line, the left line, I can know that this is not an upright surface, this is a curved surface from the right. Okay, rule number 3, the extension rule. What do we mean by that? So suppose that we have in the top this shape or this drawing. We have these 3 rectangles. We call in the engineering graphing each closed area of these rectangles, like this is area, we call it contour. So this is contour number 1, closed area means closed area. So and we have contour number 2, this is the closed area. The closed area number 3, which is contour number 3, contour. Okay, this is contour. Okay, so we have 3 contours in the top. What do we mean by that? We mean that each of these contours has a different extrude, has a different height. Okay, now how can we know the height of extrude number 1, the extrude of number 1, number 2, number 3 from the front? As we know from rule number 1, okay, but which one would be 10, which one would be 30, which one would be 20? Obviously in the same extension, for the same extension. So contour number 1 This is the height of contour number 1, which is 30. Contour number 2, what is the height to extrude of number 2? Is 10. Obviously the same thing, the same area. We can know the extrude of this contour. Contour number 3, what is the extrude? The same area, the same extension. So the extrude of contour number 3, when I add the extrude for number 3, will add 20 millimeter. Very simple. Okay, I hope it's easy to you. In the next video we'll talk about rule number 4, which is very important, the independent point. Okay, so see you in the next video. Thank you very much.